1978 question 2. The frictional force between two bodies. As we explained in the previous video on solid friction, if this is your first time watching this video, go and watch the previous video on solid friction. So I explained to us that the table like this is a body, let me say body T, and this block is a body B, a body B. When there is a block on this table, on static solid friction means for a solid for a body that is not moving on another body. Maybe we're having two bodies, they are in contact, and the body is not moving, so they are both static. They are both static. So for static solid friction, the opposition renders to the flow of one body on another body, which is friction, as we said. We said is equal to the what? Apply force. Apply force. Maybe you drag it like this. Your friction will be opposite to the what? Apply force, and they must be equal in magnitude. Equal in magnitude. That's why they are static. If apply force is greater than frictional force, it will drag it towards. If frictional force is greater than apply force, it will move this side. So let's go. So what actually happened in friction is that the motion of this one is affected by this table. Of this block is affected by this table. Do you understand? Which means there is a contact between this block and the table. Therefore, the what? The movement of the block is affected by the table, which is called friction. So they said the frictional force, that is, they actually want us to know to get the one that is correct in this option. So the frictional force acting between two bodies exists only when there is a relative motion or tendency for motion. Yes, it is correct. The statement is correct. How? Before you can say there is friction between two bodies, the body must be in contact, and the body must try to move. When the body tries to move, when you drag it, it won't move until you apply more force that is greater than the friction. So when the body is trying to move, it will experience a friction that will obstruct its movement. Do you understand? Even if you slant the table, maybe you do the table like this and you put the object here, the body might not fall. Why? Because the applied force is not equal to is not greater than the frictional force. So when it tries to fall and the friction is opposing this block, you understand? Not to fall. It's moving in this direction. The block is trying to fall by applied force in this direction. But the frictional force is opposing it. So what will happen? It will stop. So we define friction as what? A force that opposes the relative motion of what? Of bodies, two or more bodies. So let's go. So this statement is correct. Next slide. Friction acts so as to oppose the motion. Yes. Friction, you can see friction opposes the what? The applied force here. You understand? It always acts in opposite direction. And don't forget, your applied force and frictional force, they are parallel, but opposite in direction. So let's go. This statement is correct as well. And it said it depends on the normal reaction between two surfaces. What do we mean by reaction? I explained to us in the previous video that if you have a block like this on the table, it has a normal weight W according to third law of motion, which says when there is an action, there will be a reaction, which is equal in magnitude but opposite in direction. What that man is trying to say is that when you have a weight, there must be a reaction, which is what? Opposite to that weight, a reaction R. So when you have a block like this on the table, it has a weight W, there must be a what? Reaction R, or normal force N, that's what? Opposite to that weight. Equal in magnitude but opposite. Wow, why do we have reaction? When you carry this marker like this, I carry this marker like this. The marker has a particular weight which is acting downward, but only the fact that my hand is applying a reaction up to, like a force that is going upward. That's why it can hold the marker. The moment I supply reaction that is greater than what? This marker, the marker will be moving upward. The moment I let the marker force, the weight is to be greater than my own what? Reaction. What will happen? The marker will fall down. But the moment my hand supply the reaction that is equal to the weight of this marker, what will happen? It will stay on one place. So our reaction must be equal to weight. That's why the body can stay. And now, what I'm trying to tell you is that the more you have the weight, the higher your weight, the weight of your body or the table, it will determine how compressed it will be or how contact it will be with the table. If you have something of higher weight, they're very heavy, what will happen? It will touch the table more and more, and there will be higher friction compared to when we have a light body. When you have a light body, it won't touch the table, like there won't be molecular contact between two, let me just say too deep or too close or relatively close molecular contact. So which means the body will not be pressured to the surface of the table, and the friction will minimize if you have a light body. But if you have a very big body, there will be what? Contact force, like higher contact force, which means there will be what? Collision of the molecule, right? Which will oppose themselves not to move. Now, the higher you have the weight, we said the higher the weight, the higher the friction. And you know that the weight must be equal to the reaction. That is, when you have higher weight, you have higher reaction. Your table must apply higher reaction, upward force, as the body is applying what? Higher weight. So that the block will not what? Will not fall down. which means the more you increase the weight, the more the increase in reaction. And we said the more you increase the weight, the higher the friction. Definitely, the higher the reaction, the higher the friction. Do you understand? The more the weight, the more the friction. And the weight must be equal to reaction, which means the higher the reaction, the higher the friction. So let's go. They said it depends on the normal reaction between two surfaces. Yes, it depends on the reaction between the what? The two surfaces. And he said it is relatively independent of surface area in contact. Sorry, surface area. It's not surface in contact. It depends on what it's independent of surface area in contact. What are you trying to say? That it means is that if you have a wide area of table and you have a block like this is a table, this is a block. What will be the difference in friction if you have a very big table and a block like this? What will be the difference? No difference, sir. Because the area surface area of your body does not affect your friction. If you like, put small block on big table or put small block on small table. The friction that is there between the block and the table will still be the same. But which means the friction between the block and the table is independent of the surface area. No matter how wide the table is or the block is, there will still be friction. But please know this: it depends on the nature of the surface. Nature of the surface. When I'm talking of nature of surface, it can be smooth surface or rough surface. So when I'm talking of smooth surface, there will be there will be reduced friction. A smooth surface will not have much friction, but a rough surface will have got higher friction. So it depends on the nature of the surface, not the area of the surface. So it does not depend on the area of the surface, but it depends on the nature of the surface. Please note that one. So this one is correct. And they said has all of these characters. Yes, it comprises friction. The meaning of friction comprises of all these characters. So we can choose option E as the answer. So this is our answer, correct answer. So we have the following question, which is 1981, question 19. So they said if a body of mass 6 kg, we have a body of mass 6 kg, mass equal to 6 kg, rests on an inclined plane, which means it is not moving. It is at rest, which means it is a static body. Do you understand? It is for static friction, not a dynamic, not moving one. Okay? Rest on an inclined plane. The moment it rests like that, what will happen? The moment it's at rest, for law of static friction, if a body should be at rest, the frictional force will be equal to applied force. But let's go. So rest on an inclined plane as shown. The normal reaction is R. We are given the normal reaction to be R. And the frictional force F, we have frictional force F as shown in the diagram. If F is 30 Newton, we are giving our friction to be 30 Newton. And acceleration due to gravity, G equal to 10 meter per second square. So then the angle of inclination, angle theta, equal to what? So we have to calculate the angle of inclination. So let's quickly brought into the static friction for inclined plane. So as I explained then in the previous video, but if this is your first time, don't worry, you can still continue with us here. So if you have a body like this, a body inclined like this, let us go explain. This body on its own has a weight, a normal weight W, but that weight, it has been affected. Because if the weight is like this, if the body is horizontal like this, the weight will act downward, right? Vertically downward. But here, the weight has been affected. Some part of its weight will fall into front. Some part of the weight will fall like this. The one that falls in this direction, which means vertically downward, for this one will be for what? X-axis. For X-axis, this one will be for what? Sorry, this one will be for Y-axis, vertically downward. This one will be for what? X-axis. For you to know the weight, the part of this body, weight of this body that fall into this direction, I want it to fall down. And part of the body of this, or part of the weight of this body, we want it to fall in what? Horizontal direction, which is X-axis. How are we going to know the part of the weight that split into vertically Y-axis? How are we going to know it? What we are going to do right now is that we say this falling force is called applied force P. The normal weight is W, right? But the weight are split into two. The one that falls into vertical will be what? W sine theta. The one that falls into X direction will be what? W cos theta. Why is it W cos theta? Why is it W sine theta? You understand in the previous video on solid friction. I've explained the reason why it's like this. How we calculated it to W sine theta and W cos theta. You understand? Just know that the applied force that wanted to fall down will be W sine theta, and the one that wanted to fall in this direction will be what? W cos theta. Which is, do you know that the one that wanted to fall in this direction will be our reaction? Our reaction what? R. You understand? But we are not giving. You understand? Even if we want to calculate it, we are not giving the angle theta. So how are we going to calculate it? We can't get it. So let's go. And we have an opposite force, which is opposite the applied force, to be what? Our F. Frictional force. Can you see? and angle what? Angle theta. So do you understand this now? For a static body friction, if this thing is not falling, it is not falling, it is static. It is not falling at all. If it is not falling, there are one rules or two rules that are guided. The first rule is that our applied force P must be equal to frictional force. The applied force that wants it to fall down is equal to frictional force. That's why it is static. The moment the applied force is greater than frictional force, it will fall down. So for it to be static, applied force will be equal to frictional force. Rule number one. Rule number two, we say coefficient of static solid friction is equal to what? Ratio of the limiting frictional force to the what? To the reaction. R. You understand? Reaction what? R. And you can also write our reaction R to the what? F over what's our reaction R? W cos theta. So we can get it as what? So these two formula, we can use it to get our coefficient of static friction. So these two rules affect it. What is our P? Our P is W sin theta. So we can write the rules as W sin theta equal to our frictional force. And the same thing as what? Our applied force. Abi? Our coefficient of static solid friction will be equal to our frictional force over W cos theta. Do we understand this? This is the two rules. Now, let us use this formula first. Do we have coefficient of static friction? Are we given? We were not given. Did they give us frictional force? Yes, they gave us to be 30 Newton. Did they give us W? Weight. They give us weight. What is the weight? Weight is mass times weight equal to what? Mass times acceleration due to gravity, which is equal to what's our mass? 6 kg times what's acceleration due to gravity? 10, which is the same thing as what? 60 Newton. So we are giving weight to the what? 60 Newton. We are giving weight. Are we giving cos theta? No, we are not giving theta. We are asked to find the theta. Definitely, we don't know the angle. We can't get this W cos theta. So we can't get our theta using two unknown value. I didn't know we're giving this. We'll be able to get it. So we cannot use this formula. Let's try this formula. Are we giving our frictional force? Yes. Are we giving our theta? No. Are we giving W sin theta? Yes. Since this is the only thing we are looking for, we can use this above formula. So let's use W sin theta equal to frictional force, which means what's our W? 60 Newton sin, no hard Newton again, 60 sin theta equal to, what's our frictional force? 30 Newton. Oh, sorry, just say 30. So divide both sides by what? 60. When you divide both sides by 60, what do we have? We have this over 60, this over 60. We have sin theta equal to 30 over 60 equal to half, right? So our sin theta, our theta will now be equal to what? Sin inverse of half, which is the same thing as what? Sin inverse of 0.5. And don't forget, remember that sin 30 will give us 0.5. Therefore, sin inverse of 0.5 will give us 30. You understand? It's just like forward and backward reaction. So sin 30 can give us 0.5. So sin inverse of 0.5 will give us 30. So let's go. We can quickly say sin inverse of 0.5, our theta equal to what? 30 degrees. So in the option, oh sorry, I didn't write the option. So the options are A, we're giving A to be 15 degree, B to be 30 degree, option C is 45 degree, option D was 60 degree, option E was 75 degree. So what's our answer now? Our answer is what? 30 degree, option B. So option B is the correct answer, right? Correct. So option B is the correct answer. So by adding lubricating oils, when you add lubricating oils, you can see most of those engines, they add oils to them. Why are they adding oils? To reduce the friction between one iron and another one that is rolling on top of themselves. So they add what? Lubricating oil. So the people say lubrication is a form of what? Lubrication. Number two, use of pulley system. When I'm talking of pulley system, let me show you pulley. Pulley is something like this. You're having a block, you want to drag it to the floor by another mass or another block. You know that there will be friction between this rope and this particular place. And you want to reduce the friction. What will you do? You just find a pulley like this, so that the thing will be rolling on that pulley. So there will not be contact of this rope on the what? On the floor or the table. So there will not be friction between the table and the rope, so that it won't affect the movement of this thing. We just use pulley. So pulley is that thing that they used to carry weight like this. Maybe you have a load like this. You understand? You have a pulley here. Just suspend the pulley. Just put the rope here. You be here. Carrying the what? Carrying the body. So the pulley will be rolling. You understand? It will be rolling. It happened to the if you go to your street with this what is it called? This pillar, this nepa pillar. What was it called? You will see some maybe this is a pillar. You understand? You will see a particular thing fall like this on those pillar on the road. The wire lay on. So you can see those things can roll. They are a form of pulley as well. They are a form of pulleys. So and they are non-conductor too. So so use of pulley system. Number three, use of ball and bearings. Bearings. Balls and bearings. Balls and bearings. Example, most of those things that you will see on the floor like this, there will be something like tire or something like ball underneath that will be rolling. So you won't let the friction, there will be friction between that thing. Most especially go and see your washing machine. The washing machine that has something like tire or something that is rolling underneath. There will not be friction. If you want to move it, it will be very easy for you to push because there is something that is rolling under it. There is less friction between a rolling. The rolling friction is always less towards sliding friction. If you are trying to push a washing machine that does not have tire or any rolling balls underneath, what will happen? It will be difficult. But if the one that has something that is rolling, what will happen? It will be less difficult. It's something like your roll on. Do you know roll on? Do you have money to buy roll on? Maybe you watch movies to see roll on. So roll on, roll on. There is something that is rolling like ball, right? So it's make it less friction between your body and the what and the roll and the ball. So when if there is nothing like ball on it, what will happen? There will be higher friction between. So let's go. These are the three methods you can use. So friction may be reduced by lubrication. Yes, it is correct. You can reduce friction by using lubrication. It is correct, but they said they were looking for the one that is not correct. So we'll not please with this, we pick this as our. So guys, moving on to the next question. We're having 1983 question number 4. So it's still on friction, static solid friction. So which of the following statement about friction is not correct? So we are going to for any statement that is not correct. So they say what is the correct question for option A? The force of kinetic friction is less than force of static friction. Force of kinetic friction is less than force of static friction. Let us just try this thing. So we are having a body, maybe we're having a body like this inclined, and another body like this inclined. So this one is falling. This one is static. For you to be static, what will happen? Your apply force that want it to fall down is equal to what? Frictional force. Apply force P is equal to frictional force F. Right? Apply force is equal to what? Frictional force F. Apply force P equal to frictional. But here, apply force P and frictional force F. Apply force P is greater than what? Frictional force F. That's why the body is what? Falling down. Okay? So what will happen? If this body is falling, sorry, this body is not falling, right? Okay? But this one is falling. If this body is falling, what will happen? The weight of this body will not be as it is before. Maybe you're having a mass like this on the table, maybe it's an horizontal table, and you are pushing it. When I'm talking of kinetic means it's in motion, like it is moving. So when the body is moving, maybe you are dragging it on the floor like this. The moment you are dragging it on the floor, there will be less friction between this block and the table, and the floor. Why? Let us take a look at this thing. If there is, let me say, bumper or there is potholes on the road, you understand? Maybe this is the road and there is pothole, and we have a car that is moving on the road. If the car is moving slow and slow, like it's moving slowly, what will happen when you get to this pothole? It's what? It will sink and come out and come up again, right? You will feel it when you are in the car. Okay, you will feel it. But the moment you increase the speed, maybe you reverse, then you increase the speed, you speed up. Vroom. If you speed up, you won't even feel it, or you just feel a little that there is a pothole. What will happen? It will be as if the car jump over the pothole. What do you think happened? What do you think has happened? The weight of the car when it is moving slowly, maybe it is 30 Newton. You understand? But when the car is moving faster, its weight will reduce. His weight will be part of force that is using to move forward. So most of the weight of this car will have maybe fell apart, maybe fell to this side. You understand? Fell to this side. Some will have fell to this side. So the one that will act vertically downward will be less. Maybe it is 30 Newton. 10 can fall to this side, 10 can fall to this side. So one will be at the back, one will be at the in between, one will be in the what? For the vertical fall. So what will happen there? Because it is moving, the weight of the car will have split a lot, like distributed into many directions. So the one that is pulling it downward will have reduced or minimized. The fact that you can't feel the moment the weight is like the moment the weight is reduced to 10 Newton, what will happen to the reaction of the floor that is pushing the weight, the car upward? It will also reduce to what? 10 Newton instead of being 30 Newton like the previous. So the reaction is also what? Minimized. When the reaction is minimized, what will happen to the friction? The friction between the tire and the what? The floor. We also what? Reduce. Do you understand? This is the fact that the weight has reduced from 30 Newton to 10 Newton. The reaction also reduce. And the friction will what? Will reduce. Because the more the weight, the higher the friction. The lower the weight, the lower the friction. So the higher the reaction, the higher the weight, and the higher the friction. Do you understand that? The lower the weight, the lower the weight, the lower the reaction, the lower the friction. Do you understand that? So what will happen to the normal reaction force here? It has reduced. There will not be friction. So you won't feel the weight of the car is not much. You won't feel any potholes here. So let's go. If you are dragging any table on the floor, you are dragging it. If it is 50 Newton before, the moment you are dragging it, there will be some force that will have what? Scattered. Part of its weight will scatter as a force. You understand? That will join the what? The movement, the motion of the body, right? Only few will act to the table, maybe like 30 Newton will act to the table. What will happen to the weight of this thing? It has converted from 50 to 30. The weight has decreases. What will happen to the friction between the block and the what? And it will decrease. You understand? The block will not be touching the table the way it is. It will not be acting on the table the way it was before. So it will move from 50 to 30, which means the friction will also reduce. It will not be what? It will not be higher again. So let's go. They said the force of kinetic friction is less for what? Than force of what? Static friction. So if it is static, it will be 50. If it is moving, it will reduce to like the weight will reduce from 50 to 30, which means the friction will also reduce. So which means this first statement is correct. Right? The force of kinetic friction is less than force of what? Static friction. It is correct. But they say that they are looking for the one that is not correct. So we are not using this. Let's go for this. The force of the kinetic friction between two surfaces. The force of kinetic friction between two surfaces is independent of area in contact. The normal reaction, if the normal reaction is what? Unchanged. Let us quickly overview this. I explained in the previous video. I explained this thing in the previous video that if you have a table like this, and you have a block like this, and you have a big table, and you have a block like this, the friction here is also the same thing as friction here because the friction is less concerned about the area of the block. If you like, have a table like this, put the block like this. Or have a table like this, put the block flat like this. The friction between this thing and the table is still the same thing as this one and the table because you did not change the block. You only change the surface area of the block. If you change the surface area, the weight of the block is still the same as the weight of the block. Do you remember? If the weight of the block is 50 Newton, this one is also 50 Newton. So the friction will always be the same because the more the weight, the more the reaction, the higher the friction. The more the weight, the more the what? Reaction, the higher the friction. The more because weight will be opposite to what? Reaction. So they will press themselves. They compress themselves, there will be higher friction. So you understand? So it is independent of the what? Of the surface area. If you like, use smaller area. If you like, use wider area. If the weight does not change, that is the reaction. If the weight does not change, what will happen to the reaction? The reaction will not change, right? Provided the normal reaction is unchanged. They won't tell you the weight. They are talking about the weight. And whenever they are talking about normal reaction, you just bring about the weight. You'll be able to understand what they are trying to say because the weight must be opposite to the action. You understand? And equal in magnitude, as said by Newton's third law. So, third law of motion. So, let's go. This statement is correct because the friction is independent of the surface area. But friction depends on the nature of the surface area. Please don't forget this thing. It does not depend on the surface area, but it depends on the nature of the surface. Is the surface smooth, like this, or rough? If it is rough, there will be more friction. If it is smooth, there will be less friction. So the nature of the surface, it depends on the nature of the surface, but it does not depend on the area of the surface. So this statement is correct, but they said they are looking for the non-correct one. So we are not using this. Let me use this blue marker. We are not using this. They said the force of rolling friction is less than the force of sliding friction. Force of rolling friction is less than the force of sliding friction. Let's try and see. It's something you can do on your own. You can experiment on your own. You're having a block like this, a circular body, a rectangular body. This is 50 Newton. Bachelor, why do you just like 50 Newton? I beg you. Now 50 Newton, they come from my mouth. You have a block like this. You understand? This body is rolling. This body is static. You now say which one is having higher friction? Do you know a rolling body? What is happening? It's already on motion. Will it be acting as 50 Newton? No. Most of its weight will not act downward again. Maybe only 20 Newton will be acting downward. The rest will have scattered. They will have split the rest because it is rolling. It is on motion. It is kinetic. It is the same thing as this. So the moment it is rolling, what will happen? Okay, if I want to, let me try and roll this thing. Let me try and slide this thing now. Let me slide this. I'm bending this thing now. You can see it does not fall. Now, let me put another marker at this angle. See the angle. You can see it fall. The same angle, but let me slide it. You can see it is not falling. But at the same angle, if I put it like this, it is falling or it's not falling. So there is the rolling friction. So the friction between this marker and this paper, when it is sliding, it is greater than the friction between this marker and this table and this paper when it is what? Rolling. So the friction is less when it is rolling, but higher when it is sliding. You can see it is not moving. The friction is high. But you can see this one can move. The friction is less. So the rolling friction is less than what? Sliding friction. Let's go to, so this statement is correct, right? But they said the one that is not correct. So we will not pick this option. The angle of friction is the angle between the normal reaction and the frictional force. Let us try what they are saying. So we are having a body like this on the table. This is our weight. This is our reaction R. This is our friction F. They said the angle of friction is the angle between the normal reaction and the force friction. They said the angle of friction will be the angle between this and this. Is it true? No. Angle of friction is the angle. This is reaction, this is friction. Do you know that between reaction and friction, if you want, this is reaction, all right? If you want to find the resultant force, what will be the resultant force? Resultant force will be maybe like this, resultant force L, maybe we have a resultant force L. Resultant force means the net force between the what? Reaction and friction. You understand? We understand when we are doing vector force. We will find the resultant force between these two forces. So the resultant force is what? L. The angle between the reaction and the resultant force of friction is what we know as what? Angle of friction. So not the angle between the friction and resultant reaction. No. The angle between the reaction and resultant force of friction. Not, this one is correct. Not angle between the reaction and the friction, but angle between the reaction and the resultant force of friction. Do you understand? So is option D correct? No. What did they say they did not? What did they say they want? They said they want the option that is not correct. So this one will be their what? Answer. But let's just check. Let's just check option E. Option E, friction may be reduced by lubrication. How can we reduce friction? I've not explained this. Let me quickly brush up. How to reduce friction? How to reduce friction? How do we reduce friction? Bachelor, I don't want friction to be happening in this thing. I don't know how we do. There's friction between this marker and this paper. How are we going to reduce the friction? Okay, no wala. Number one, adding lubricating oil. If you're adding lubricating oil, those engines, you can see most of those engines, they will say, please put oil in that engine before you use it. Oh, why are they putting oil? To reduce what? Friction. So by adding oils to what? To engine, we reduce what? The friction between one particular body. So guys, we are still on 1983 question 5. So we are having a brick on a floor which is pulled by a block. A brick at rest on an horizontal table is pulled on a horizontal floor as shown in the diagram above. So if the force of friction on the block, they want us to know the correct answer for this. What will happen to the force of friction on the block? That is the friction between the brick and the floor. You understand? The force of friction on the brick. So they said increases if pull increases but the brick does not move. Let's quickly examine this. We are having a brick like this. You are pulling it like this. Maybe we are pulling it with force of 10 Newton. And it is static. It is not moving. Because they said a brick is at rest. For it to be at rest, it is a static solid friction, right? It's a static. It is not moving. And what is the rule of static solid friction? Your applied force, P, must be equal to what? Frictional force, F. So if our applied force is 10 Newton, what will happen to frictional force? 10 Newton. They must be equal. But if it is moving, what will happen? Your applied force is greater than frictional force. But if it is static, non-moving, what will happen? Your applied force is equal to frictional force. But I'm telling you that if the friction here is 50 Newton, friction will not tell you that it is 50 Newton. It will hide it. If you apply force of 10 Newton, friction will show you that it has 10 Newton. If you increase it to 20, you increase it to 20 Newton. Friction will also show you that it has 20 Newton. If you increase it to 40, it will also show you that it has 40 Newton. If you increase it to 49 Newton, friction will also show you that it has 49 Newton. If you show that you have a force, if you apply a force of what? 50 Newton, friction will also show you 50 Newton, and the block will not move. But do you know that the only friction that this table has is what? 50 Newton. It has reached the minimum, like the maximum, the limits. You have applied force, you have increased it to the limit friction that this table has. We call this one limiting frictional force. So for you to attain a limiting frictional force, F, what will happen? You must have put this thing to the maximum value. Do you understand? So the moment you now show you that you have 50.1, this thing will start moving gradually because this one do not have more than 50 Newton. The friction does not have more than 50 Newton. What will happen? You just see the block will be moving gradually, which means your force is greater than the frictional force. You understand? So for you to have higher frictional force, go and check my previous video on static solidity. I explained better. So I said for static dynamic friction, your applied force must be greater than what? Frictional force. So for you to attain limiting frictional force, you must be supplying applied force to the maximum level. So you understand? So they said, increase if the pull increase. If you continue pulling this thing, you'll be increasing your applied force. What will happen to the frictional force too? It will be increasing till it reaches the maximum value. So let's go. But the brick does not move. You are increasing the applied force and the brick does not move. What happened? The friction keep increasing as you are what? Increasing your applied force. Because if it is moving, which means your applied force is greater than friction. But if it does not move, as you are increasing the applied force, the friction is also increasing. That's what they are trying to tell you. So this statement is totally correct. Totally correct. The more you are applying the applied force, the more the increase in what? Frictional force. And it will not move until you now reach one level of applied force that is greater than frictional force. The thing will now start moving. So which level will you reach before you overcome the power of this friction? The level is called limiting frictional force. You have reached the limiting frictional force. You have applied force that has reached the limiting frictional force. So let's go. So the option B is directly horizontal to the right. They said the force of friction of the brick is directly horizontal to the right. You are pulling it to the right. Where will the friction go? Opposite direction, the left, Abi, in horizontal. So if you have an applied force that is like this, your frictional force will be parallel to applied force, but in horizontal direction, right? But in opposite direction. Opposite direction. You can see. So your friction is supposed to go in the left, not right. It's directly horizontal to the right. No. Your friction is supposed to go in a left direction. You understand? Friction must oppose your applied force. Your frictional force, they said the frictional force decreases if an identical brick is placed on the first. What are they trying to say? They said, if you are having a brick like this, as we are having here, and we are pulling, if you add another brick to this thing, you understand? What will happen if you add another brick? Maybe this one is W before, this one is W1, this one is W2. So what will be the total weight? Total weight will be equal to W1 plus W2. We will be having higher weight. Increase in what? Weight. Your weight will increase. If your weight increases, what will happen to our reaction too? Our reaction R will increases. You understand? Our reaction R will increases. You forgot it. Don't forget in the previous video that whenever you are increasing the weight, the reaction will also increase so that to make the table stable, to make the brick stable. Because if your weight is greater than the reaction, what will happen to the brick? It will fall down. But if your weight is equal to the reaction, it will stay. So the more you are applying the weight, the more the reaction will increase. So this thing will not close to each other. They will not close. The more you are adding more weight, they will close. They will be very close. This thing will be very close, more close to the table because you are adding more weight to the one that is there. So what will happen to the brick and the table? They'll be very, very close. And something that is very, very close, there will be higher friction between them. But if they are not too close, they are just touching themselves small. The friction will not much. But they are touching themselves very well. There will be higher friction. So they now said the friction decreases if the identical brick is placed on the first. They now said the friction will decrease. No, friction will not decrease. The higher your weight, the higher your reaction, the higher the friction. The more you add weight, the more there will be the action that will pull it back, and the more that will be the friction that will be between both of you. But the lower your weight, this one will not supply too much friction too, because your weight is not too much. So, and the reaction between them will be reduced, right? Now, your friction between them will also what? Reduce. So, this option is not correct. So, is 0. The frictional force on the brick will be 0 if brick is pulled hard enough to make it slide. If you pull it, you are pulling this brick, pam, 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 and it is sliding, it is moving. It is no more static friction. It is no more static, it is dynamic. What will happen? It is true that when you are pulling a block, the friction between them will reduce, and the block is moving. If the block is moving, the friction between them will reduce, because most of the force, I explained in the previous video, that the previous question, that the most of the force will scatter away. You understand? They will scatter away. So we have only limited force of weight. Most of its weight was scattered away. So only limited weight will be there. That's why I use a pothole, a car moving on a pothole, a car moving, and it's come across a pothole. If the car is speeding, you won't feel the pothole. If the car is moving slowly, you will feel the what? Pothole. So because the weight of the car will increase when it is moving slowly, but when it's moving very fast, what will happen? The weight of the car will be less. So there will be low contact between the tire and the road. You understand? When there is no contact between the tire and the road, what will happen? It won't feel the bumper. It won't feel the pothole. So the same thing here. If you are pulling a block, a brick on the floor, the friction between that brick on the floor will reduce if you are increasing the speed. But the friction between the brick and the floor, it can never be 0. It can reduce, but can never be 0. The only condition that can make this brick and this table, the friction between them, the reason that can make them be 0 is when you take away this brick from this block. Maybe this is the floor. You now take the brick away from the floor. You lift it down. What will happen? There will be no friction between them again. The friction will be 0. But the moment the brick is still on the floor, there will be friction. Even if you are speeding 1,000 kilometer, sorry, if you are speeding 3 kilometer per second, there is no way you want to do it. There will still be friction, but limited. Even if you had lubricating oil, you had ball and bearings, you have pulley system, there will still be friction, but limited. It can never be 0 unless you take away the brick from the floor. So this statement is not correct. It can never be 0. They said the frictional force on the brick change if the brick is turned to its side. They said if you change the side of the brick like this, if you change the side of the brick like this, maybe this is the brick, you now change the side to this form. What will happen? The friction between the table and the brick will still be the same, because if this weight is 50 Newton, this one weight is also 50 Newton, so it's not changing. You only change the surface area. The surface area of this one is wide. The surface area of this one is what? Is low, right? Area is small. Area is what? Big here. But do you remember that I told you that what in the previous video? Question I've mentioned it like 2 times in the question and the normal topic on this solid friction, that the friction between bodies that are in contact is independent of the area of the surface area. Independent of the surface area, but it depends on the weight or the reaction, not the surface area. Although it depends on the nature of the surface. Don't forget, if the surface is rough or smooth, it depends on the nature of the surface. Is this rough or smooth? But it does not depend on the surface area. Is it the area wide or small? No, it does not depend on it. So maybe you change it or you do not change it, the friction will still be the same. So the surface area does not have anything to do with what? The friction. So this option is not correct. Which one is correct? Option A. So we choose option A as the answer. So we have 1985 question 8. So what is the question? The question says a metal block of mass 5 kg. We're having a metal block. Mass is 5 kilogram. Lies on a rough horizontal platform. We have a horizontal platform. So the block lies on horizontal platform like this. So if the horizontal force of 8 Newton is applied, you now apply a force to it horizontally. Let's say this side, you drag it this side, apply force, horizontal force, which is what? 8 Newton. You apply a force of 8 Newton to it. To the block through its center of mass. You apply it through the center. Okay? Just slide the block on the platform. The force you apply, you just try to slide it. What are they trying to say? Just slide the block on the platform. Do you know that what they actually mean is that there is a frictional force? You know, frictional force will be opposite to the applied force. So the friction of F in this direction, Do you know that your friction will increase as you increase? Maybe you apply a force of 5 Newton. Your friction will be 5 Newton, 6 Newton, 6 Newton, 7 Newton here, 7 Newton. The moment you reach a bit, you are about to slide the block. You are about to slide the block. What do you mean? You have applied a force that is equal to the limit of this friction. That's why you are about to slide the block. That means you have attained a limiting frictional force. A limiting frictional force. Don't forget. Limiting frictional. You have attained a limiting frictional force. For you to just, where is it? Center of the mass, just slide the block. Just slide the block, which means not that the block is moving. The block is about to what? To move, which means our applied force P is equal to frictional force. You have applied a force that is maximum, that has reached the what? The limiting frictional force here. Which means our frictional force on the table, limiting frictional force on the table equal to what? 8 Newton. So we are having that, okay? Then the coefficient between the block and the platform. They ask us to get the coefficient between the block and the platform is, so the coefficient is what? What is the formula for coefficient of static solid friction? Our coefficient of static solid friction, the formula is the ratio of limiting frictional force to the reaction. Is the ratio of what? Limiting frictional force to the reaction. Don't forget this formula. Coefficient of static solid friction, the ratio of limiting frictional force to the reaction. So what is our limiting frictional force? You know, our applied force is 8 Newton. And for any static solid friction, our frictional force will be equal to what? Applied force. You can replace it as applied force over reaction. And don't forget that applied force is P, frictional force is F. Our reaction is like this, R. Our weight is like this. Our weight is always equal to what? Reaction. So you can replace reaction with weight. You can also write it like this, F over weight, or you write it like P over weight. You are still saying the same thing. These formulas can be used to calculate the coefficient of force, solid friction. So now, what are we giving? We are giving applied force P. Are we giving weight? Are we giving reaction? No, we are not giving reaction. But are we giving the weight? Yes. What is our weight? Do you know that we are giving the mass to be 5 kilograms? And weight is equal to mass times acceleration due to gravity. So we can really say our weight is equal to, what is our weight? 5 kilograms. Our mass, 5 kilograms times what's acceleration to gravity? 10 meters per second square, right? So our weight is equal to 50 Newton. Wow. Our weight is 50 Newton. So we can quickly calculate our coefficient of static friction to be what are we giving? Applied force, right? Which is the same thing as frictional force, which is 8 over, what is the weight? 50. So you can make use of this formula, 8 over 50, you understand? Just divide with the same thing as what? 4 over 25. I think around it will be around 0.16, I think. You can quickly do this 24 here, 4 here, 25 here, 25 in 4, 0 points in 40, 25 in 40, that will be 1. You understand? 25, we have, how many left? Because in your JAMB, we will not be allowed to use calculator. So try as much as possible to do the calculation on your own without calculator. So what we left here, what we will remain 15. So 25 in 15 does not go add, which is what? 150. 25 in 150, that will be 6, right? Yeah, that should be 6. In 5, 125 is 6. So 25 times 6, 150, 150. So everything will be what? 0.16. So our answer here is what? 0.16 answer. So this is the answer to the question. This is question 11. When a box of mass 45 kilograms is slid along a horizontal floor of distance 3 meters before coming to rest, what is the coefficient of limiting friction between the block and the platform? Let's try and draw it here. We're having a block, a platform. So the block is 45 kilograms. It is slid along horizontal floor for distance of what? 3 meters. So before it comes to rest, before it now stay in one place, maybe it stay here. So what is the coefficient of limiting friction between the block and the platform? So when the block is moving, it later stops because of the friction. You understand? This is a kinetic friction. You understand? We are asked to calculate the coefficient of what? Limiting friction between the block. As we explained in the previous video, to calculate coefficient of solid friction, which is coefficient of solid friction, U equal to our limiting frictional force, ratio of limiting frictional force to the what? Reaction. That is limiting frictional force over reaction. This is applied force, P, frictional force, F, our weight, W, our reaction, R. Do you understand? So if it is static solid friction, our frictional force is the same thing as apply force over reaction. Or you say frictional force over weight. Or you say apply force over weight. Please don't forget the formula. You have to memorize them. You have to memorize them. So for you to have a particular thing, so what we were given here is that we will be needing the weight and the limiting frictional force. So we have to calculate the coefficient of what? Limiting frictional force. What will actually happen? For this thing to stop, which means our apply force is equal to what? Frictional, limiting frictional force. That's why it's able to stop. You understand? For a body that is moving to stop, which means you apply force that you have been applying, it is now equal to the what? Frictional force. That's why it stopped. It is now static. You understand? So for you to know the coefficient of static frictional force now, so which means we are going to use this formula, coefficient equal to what? Apply force over weight. You understand? Since we are not giving the reaction, and our weight will be always equal to the reaction, so we can get weight by doing 45 times acceleration due to gravity. We are looking for coefficient of static friction. Are we giving apply force? No. But how are we going to get it? What are we giving, self? We are giving distance to be 3 meters, weight to be what our mass? Mass times acceleration due to gravity. What's our mass? 45 kilogram times what's acceleration due to gravity? 10 meter per seconds. Are we giving apply force P? Apply force P? No. Our coefficient of static friction? No. We are not giving. So we must get this apply force. So that we can calculate our what? Coefficient of static friction. How are we going to get the apply force? Since we are only giving the what? Do you know that apply apply force P, you know, force is equal to what? Mass times acceleration, right? What is mass? 45. 45 times. What is acceleration? We don't know. How are we going to get acceleration? But we are given distance. Can we get acceleration from distance? Which formula? We make us get acceleration from distance. You understand? So, which formula can we use to get an acceleration from a distance? So I think the question is not complete. So let me quickly add it. I've realized it's not complete. Please sorry for this inconvenience. So of distance 3 meters. From here, there is a missing words. There are some missing words. Let me write it here. After distance 3 meters, there is something to be here of initial velocity of 5 meters per second. So we have forgotten, we are giving initial velocity u to be what? 5 meters per what? Second. So 5 meters per second, and we before coming to what? To rest. So what will be our final velocity when it has come to rest? Our final velocity v will be equal to what? 0, right? So since we are given the velocity and we are given the distance, we can calculate our acceleration then. So let's quickly do this. So using a formula from what? We have v equal to u plus at. We have v squared is equal to u squared plus 2as. From motion, formula of motion, we have s equal to ut plus half at squared. Are we given time? No. So we can't use this. Are we given time? No. So we can't use this. We can't use the two formula above. So what we are going to use here is this, because we don't have, this one does not require time. So let's quickly use this. If we want to use this now, our v, what's our final velocity? 0. Right? Our initial velocity is said to be, what's our initial velocity? 5 meters per second. And what's 2 times, what are we looking for? Acceleration times, what's our distance? Distance s is what? 3 meters, right? Distance s is 3 meters. Please don't forget, we will replace s, the distance is the same thing as s in this formula. So which will now be equal to 2 times 8 times 2 times 3 is 6. So our 0 equal to 5 squared. Please don't forget the square. 5 squared plus 6a, right? So 5 squared plus 6a. But do you know that this acceleration is not an acceleration, it is a deceleration, because the block is moving from a speed of 5 meters per second to 0. Is it acceleration or deceleration? Acceleration or deceleration? It is deceleration. And acceleration always take plus a. Deceleration will take minus a. Do you understand? So what's supposed to be here should be what? Minus a. Please don't forget. So it is a deceleration. It is coming from a higher speed to lower speed. From something that is moving faster to lower. So what will happen? Minus. So when you bring this one to the other side, what will it be? our 6a will be equal to what? 5 square. Do you know understand what I do? You will add 6a to both sides. Just add 6a to both sides. Add 6a plus 6a plus 6a. You know, plus 6a will cancel minus 6a. What will it mean? So 6a plus 0 is the same thing as 6a equal to 5 square. Sorry, this is not clear enough. So let me rewrite this. So we can quickly say our 0 equal to 5 square plus 6a. So add 6a to both sides. We said it's a deceleration, not acceleration. So it will be what? Minus 6a, right? So adding 6a to both sides plus 6a plus 6a. What will happen? We have 6a will cancel 6a here, right? So we have 6a equal to 5 square. So making a as subject of formula, what will happen? A acceleration will be equal to what? 5 square over 6, right? You divide both sides by 6. So divide both sides by 6. So you get, we have 5 square over 6. So our acceleration equal to, what is 5 square? 25 over 6. Do you understand? So what will be our force like that? We say apply force is mass times acceleration. So apply force will now be equal to 45 is our mass. What is our acceleration? Times 25 over 6. So now we've gotten our apply force. But where are we going? To calculate the what? Coefficient of static solid friction, right? Coefficient of limiting frictional force is what we are looking for. So we are going to no. So what we are going to use here is that what? Coefficient of static solid friction equal to, what's our apply force? This is our apply force. Our apply force will be 45 times 25 over 6 divided by, this is our apply force, right? All these things is our apply force divided by, what is our weight? Our weight is mass times acceleration due to gravity. I think I calculated it. 45 times 10, right? 45 times 10. So if you want to turn this division to multiplication, what will it be? Coefficient of division equal to 45 times 25 over 6 multiplied by 1 over 45 times 10, right? You understand? So what will actually happen is that 45 will cancel 45 and 10 here. So when 45 cancel 45, what will it be? Coefficient of static friction equal to 25 times 1, 25 over 6 times 10, 60. We have what we call 25 over 60. Can we reduce this thing? Yes. 5 here, 5 in 25, 5 over 5 in 60. That would be like, that will be around 12. I think 5 times 12 is 50. So 5 over 12. So our coefficient of static friction is equal to 5 over 12. So let's check the answer. Do we have 5 over 12 here? Yes, option B. So option B is our answer. It is what? 5 over 12. So this is said to be correct option. So guys, moving on to another question, which is 1987 rather. 1987 question 11. So the coefficient of static friction between 40 kilogram crate and the surface is 0.25. The coefficient is 0.25. Find the magnitude of the minimum force needed to keep the crate stationary on the concrete base inclined at angle 45 to the horizontal. What they are trying to say here is that there is a concrete inclined at angle 45 to the horizontal, 45 degree. There is a concrete on it, and the mass of the concrete is what? 40 kilogram. Do you understand? So the coefficient of static friction between the concrete and the surface of the between the crate, this crate and the concrete is what? The coefficient between the crate and the concrete is 0.25. Our mass equal to 40 kilogram. So if our mass is 40 kilogram, what will be our weight? Our weight should be what? 40 times 10. You know, acceleration due to gravity is 10 meters per second. And weight equal to mass times acceleration due to gravity. Acceleration due to gravity. So this is 40 times 10, which is equal to what? 400 Newton, right? So our weight is 400 Newton. So now, let's just leave this around. So now, what are we asking? What are we asking? They said the coefficient of static friction, they are giving us. Find the magnitude. Magnitude means amount. So magnitude of the minimum force the amount of the minimum force required to keep the concrete stationary on the crate. Definitely, this concrete is trying to fall. I think. So they are now looking for a force or a minimum force. What type of force is that? To make this particular crate concrete to stay, like to remain stationary, like to stay. What are they asking us? They are which force will make something that want to fall down to stay? Something want to fall down by apply force P. So what we hold this thing not to fall down? That will be friction. Friction F. So they asked us to calculate the friction. But already they gave us coefficient of static friction to be 0.25, which means there was already a friction that is happening to this thing. Why are they asking us to add more friction? Why are they asking us to add more friction that will make this thing stable? Okay, we don't know yet. Let's go. We are having our normal reaction. This is our reaction R, which is the same thing as what? W cos theta. Don't forget, I explained to you that when you have a weight of mass W, you understand, and it is inclined at certain angle, what will happen? The weight will split into two. Some part of the weight we want it to fall in horizontal direction. Some part of the weight we want it to fall in vertical direction. The one that want to come in vertical direction is the apply force. Your weight will split into two. One will act as an apply force. One will act as what? Horizontal force. So now, when we act as horizontal force, which is the reaction, you understand? So now, our apply force P is the same thing as what? W sine theta. So our reaction will be what? W cos theta. I hope you understand this. So we understand that what? Our apply force is W sine theta. Our reaction is W cos theta. Fine. Friction that is holding it is F. Okay. So where are we going? We have coefficient of static solid friction to be the ratio of frictional force to the reaction. What is our reaction? Our frictional force is the same thing as F. What's our reaction? W cos theta. W cos theta. So to make frictional force and subject of formula, frictional force will be equal to what? Coefficient of static friction times what? W cos theta. So this will be the formula for our friction. What are they asking us to calculate, Seth? The force required to take this thing, to hold it, not to move. Definitely, this thing has been trying to move. This thing has been trying to move, but they want it to remain static. Let us check the frictional force that was there before. What is the frictional force that was there before? Our frictional force will be equal to F equal to, what's the coefficient? 0.25 times, what is our weight? 4 times 10, 100. 4 times 10, 40 times 10, 400. 400 cos 45, right? This will be our friction before. What is our apply force before? Our apply force, P, will be equal to W sine theta, which is the same thing as, what's our W? 400 sine 45 degrees. Do you understand? So they have applied the applied force that was acting on it is this, is 400 sine 45 degree. The friction that was resisting it is what? 400, 0.25 times 400 cos 45 degree. But this thing is still trying to fall. So they now say how many force, minimum force, we will require to hold this thing not to fall again. That is, we need more friction to hold this thing not to fall again. How are we going to know? You will understand now. Which means our applied force, weight, P, is greater than the frictional force. The remaining force, so if you now say apply force minus frictional force, you know, this thing is moving now. So apply force is greater than frictional force here. That's why it is moving. We now need more force to hold it not to fall. So apply force is already greater than frictional force. If we minus the frictional force from the apply force, what will it remain? The force that we hold this thing not to fall. You know, our apply force will be equal to frictional force plus the force that is using to move downward. Maybe the force is the force D. So apply force D is the force that is enable this crate to move downward. So apply force will be equal to what? The frictional force that was there. You understand? That hold it plus the remaining force that the block is using to move downward. So if you now want to get the force that the block is using to move downward, what will you do? You will remove your frictional force from the apply force, which is this. So if you remove frictional force from apply force, we will get the force that is using to move downward, D. The force that is now using to move downward, D, is the remaining force that is on this block. The remaining force that is on this block will be the amount of the friction we use. Maybe the remaining force on this block is like 50 now. that is using to move downward. How many friction will you supply? 50, so that it can hold the block. Do you understand the method? So the force required to hold the block, not to move again, will be what? Will be the remaining force that this block is using to move downward after the friction has acted. Let us calculate. You understand?